Hello everybody. So first of all, welcome to my YouTube channel. I will be going to explain you AtCoder top four problems which had asked in the like this is 9th October, sorry 8 October. So be with me and I will explain you these four problems: robot balance, robot weight, robot factory, and robot customize. So I will going to explain you each problem, how to approach and how to work on that problem so that you can also think that part in the contest. Okay. So let's start the first problem, which is the robot balance. Okay. Let me just do this. Okay. First problem is robot balance. Okay. So what the problem is saying to us that it's very easy problem. Takahashi can combine a head part and a body part to create a robot. A robot falls if the weight of the body part is that greater than the weight of the body part. Okay, so it's just simply saying that if you have like H and B, right? So if you have H and B, so you just have to tell that like head part should be less than that B part. Okay, so it is just saying to just like some very easy part, like you have a head part and a body part. Okay, what you have to do, this should be always happening. Okay, so as you can see that here head is less than B, sorry, head is greater than B, so you don't have to like you have to tell that how much you have to add here, how much to add here, so that this body part at least like passing this inequality, right? So you can see that. So if you just see that, like if head is greater than body part, what will the case? We have to just add what, body minus head of absolute, right? This is like absolute, okay, mod. So if we add this to the body, if we add this to the body, then we can say that yes, our body is right now at least greater than equals to head. Okay. And the next thing is we if they are what we can say that if the body is already greater than head, so we don't have to do anything. Okay. So like the very easy code. So just see my code. Okay. So that you can get. Okay, so you can see here, I just take two inputs, max of a minus b, like and 0 comma long long. So you can take the modulus also if you want to do. Okay, so this is about the first problem. Let's move to the second problem. I hope it is clear to you. And please, guys, like I'm beginning this new channel, so please like give your comments and what's the quality you need from me so that I can do that whatever you want. Okay, let's read the problem without wasting your time because I want that you will get this problem very quick. So you have a robot and initially the weight of the root is robot is X. This robot has n types of parts that can be attached simultaneously, type 1, type 2, type n. The weight of the type is Wi. Initially, but none of the n times part of the attached robot. Please following the Q queries in order. The ith query is given by an integer pi. Okay. So the problem is saying like you have the four queries. Okay. So like that day the contest was something body and something parts, theme, something like that. Okay. So I'm explaining you what this problem is saying. So I'm explaining you here what the problem is saying. Wait, I have to write it for 4, 15, 92, 15, 92, 65, and 35. Okay. So we have this. And we have 4, 3, 1, 4, 1. 4, 3, 1, 4, 1. Okay, 4, 3, 1, and 4 and 1. Okay, 4 and 1. Okay, so what I'm see what the problem is saying. This is n. This is the length of array. This is queries, and these are four queries. Okay, so what we have to do here in this problem is just let me read one more. Okay, so I think in the first query it has three body. The weight of the part is this. The second query attach the type one part of the board. The weight of the robot becomes 96 plus 115, 111. And the third query attach the by 4 to the right. 1 plus 35. Okay, so what we have to do, see, we just have to keep a track of mm, boolean. So we have a boolean here. So what to do when we are taking this three, so this three didn't take any time, right? So we have to take it and mark it blue, right? We have to mark it one. Did we take one? No, we have to take one. Okay, just add it in answer and mark it one. Did we have taken four? No, we have not taken so mark it one and take it. Did you taken one? Yes, we had taken one. So just mark one as zero and subtract 15 from your answer. So it's like a very brute for problem. You just have to process n queries and the something like you just maintain the state of each body, everything, right? So I think that especially is pretty high. You just have to create a map. Okay, just keep a map and when processing queries, mark these three as true when it comes. Mark this is true, this is true. When this is one, when like if MPL of one is true, right? It means that we have taken that. So we just have to x minus equals to the value, or you can say the vec of one, the value we are getting. Okay. So that's all about this problem. Just see the code. I think the problems are very easy. Okay, so just see, like we have taken the input, we have taken the map, and then we are processing each queries. We have x, we have seen x. If the MPL of x equals to one means if the value you have taken, just set the value to zero, like the flip the state, or just subtract it, print it, and that's all. Just print the value. I think. Okay, so I think this is also very clear to you. Let's move to the third problem. This one is robot factory. Okay, so Takahashi has combined a head part and body part to create a robot. A robot falls over if the weight of the head part is greater than the weight of the body. Currently, he has n head parts and m body parts. The weight of ith head part is hi grams and the weight of ith body part is pi grams. He wants to create a total of k robots that do not fall appropriately combining the parts he has determined whether he can achieve his goal by combining the parts well. Okay, so first of all, it's like these problems are so easy. You just have to like think how we can solve it. Okay, so when you look at the constraints, so we have to solve this problem in big O of n or big O of n plus one m, right? We cannot go beyond that. Okay, so if we just try to look at the problem, okay, he want to create a total k robots. So we don't know anything, but we know that we have to create k robots. Okay, that do not fall over by appropriately combining the parts. So it means that we want K robots, right? We want K robots. So for getting K robots, what we want? A robot can we make if we have head part less than equals to body. Okay. And he had given me head part, he had given body part. So what we have to do here is see what we have to do here is we have a head part, we have a head part, we have a body part. So what to do? We just have to make a head part to the body part. So like mapping we have to do. And we have to tell how many and we can make first of all just try to think like what the max answer you can make what the max answer you can make so the max answer we can make is the n right because each head is get mapped to each body so we can look at max like n robots and you can see here also like this one okay so these are the simple proofs you are like always look into this okay so what's the best approach we can do always ask this thing in your mind whenever the order not matches whenever the order not matters, can we sort the array? Can we sort the array? Always ask this problem. Always ask this problem in your mind that can we sort the array? So when you take this, so if you just sort them, okay, so we just like sort them one, two, two, one, two, two, and then we have a seven, and then we have a eight and eight, and we have one, two, four, five, eight, one, two, four, five, eight. Because what we want to do, I will try to see what the robot max robot I can make. Okay, if I get that, what's the max robot I can make? If that is greater than equals to k, okay, means yes, I can definitely do that. I have to print yes or no. So just see, can we assign this to this? Yes, because the head part is one, body part is one. Okay, can we assign this to this? Yes. Can we assign this to this? No. Yes, sorry, yes, we can do this. Can you assign this part to this? No. Why? Because the head part is seven, so we have taken it, and for this it we can take it. So we can do this. We can get this, and this. We can get five. So if you have three, four, two, whatever the value you can always make this. So it's a two-pointer question. You have to just see and sort it. So that's why the top order, like you can see the standings, the top order did it very fast because the problems are easy, not they are much complex. Okay. So this I'm showing the solution for this one. Okay. See, we have array, we have again an array. We will shorten them take two pointers, just iterate in them. If AI less than 10, then iterate both of them, CNT plus plus, like what the max robots you can make. Because if this criteria happens, CNT plus plus you can do, and then you can simply just give your answer. Okay, so this was like CY means C out yes and C out no. And in that order, please make sure whenever you're printing it, just make sure you had make here yes or no, whatever they've mentioned, because in the code force generally this dot matters, but in that order it matters. Okay. So let's move to the D problem. Okay, D problem was quite good, not very good, but okay. It was like not that much complicated. So if you just see the problem, 400 points. So one more thing, never ever get underestimate the problem. Okay, like so always try to read the problem, try to make simple points, and see how you can solve those points and some necessary conditions to solve the problem. Okay, so let's see what we have. So see, there's a robotic condition consisting of head and body. Robot is n types. The part something is type saying. Yeah, I'm explaining you what the problem is saying. You can read it on your own. Okay, I don't have much time to explain, so that's why I'm doing it. Okay, so we have this and we have this. Okay, but we have 897 93. Okay, see what we have to do in this problem. You have to take some value. So what is this? So this is the like cost. Like this is the cost. I think. Okay, so these are the like you can say the weights. So either you take this, like suppose this is the body weight and this is the head weight. So either you can take this value, like either you can take this token for the body weight or take for the head, right? So if you take it for the head, so your value, so you have something beauty value kind of, you have a happiness value that will get increased by this head value and this beauty, like sorry body. So if you take this token for body, you get 41. If you take this for one like head, so you will get 59. Okay. Okay, I hope you're getting point. If you take this two for your head, you will get 35. Sorry, you get 65. And if you take this two weight for your head, you get 65. If you take this two for your body, you will get 35, right? So what's the point is saying so what you have to do basically you have to arrange them, you have to arrange these configurations so that you give like this is a valid configuration, sorry, this is a valid configuration like you have 1 and 2 and then 8 because why it is a valid configuration because you have a 1 and 2 and you have a 8 means the total weight is here is 3 and the total weight is here is 8, so the body part is greater than or equals to 8. That's the theme of the problem. So and what the value will get, so in the 8 we had taken the body value, so if this is the head, this is the body, so I get 93 and here I get this and this. So my motive is to maximize the happiness value, which is this. See, now you had, I hope you get the problem. So what we can do, first of all, look in the constraints. We have only this, okay, and the weight is also high. So first of all, try to approximate the complexity of the problem because the complexity of problem you can't change. Maybe you can confuse about the uh, problem, some observation points, but you will never have to confuse about the complexity. You have to solve this problem in n into like n square. You can use n square, and even you can use n cube also because that was 500 cube. So if you are using only int, not long, that got accepted. Okay. So like why I'm saying int, not long, because long give you MLE. If you use something like DB or something. Okay. So what we can do? So what we can do is, so it's a very simple like knapsack problem. If you don't know knapsack problem, please read knapsack problem from here, like GOG and from where you want to read. So this is read knapsack problems. So there are only two conditions: take or not take in an abstract problem. And generally, now what next new things happen here. So when you are take means you are giving to the head part that I am assuming, and when not take, you are giving to the body part. So what we want is we have to something state like DB of state. So we want an index. Okay. Then what you want? See, you are at some index. What you want? Just ask this thing to your brain to solve any DB problem. Okay. Not any because as we go far, the problem is going harder. But just keep thing in mind. What you want? You have an index, okay. And what you want next? Uh, we want that we have a like index, and then we have the value, right? The value, not the sum, because if you store these values as an index, so this will not you can store. You can store weight, right? And see what the like every time what you want. We have an index, so we should have what the weight we have in body part weight and what the sum we have in head part. Okay, so we have something like this configuration. So if we just try to look, index can go up to 500, and here we have here see now body part weight is not 500. See, this is not 500 because this is the accumulation, right? This is the accumulation you have. So body part weight, because suppose you have first one time, like see, we have 41 here, then we have 65. So this will get accumulated. Okay, no, so this one plus two. So this will get accumulated, one plus two. So one plus two and so to very value. So this will be one plus two plus dot dot up to 500. So this is actually n into n plus one by two. Okay, so which is something around 500 into 500 1 by 2, which you can calculate in your calculator. And this will be also same that because this is also same. Okay, so we can say that like this approach will definitely not work. So what we can do, like this I had like you can see in my submission I had a runtime error because I get MLE. You can see here. That's why because I had submitted this code. But if you just look it carefully, is we really need this state? No, because this is simply the totals. If you have this state, you can get this one by total sum of weights means this sum, this 1 plus 2 plus 8. So if you have this sum, simply subtract your the weight of body part which you have state here, then you simply get the head part weight. Okay. So in the base case, like when your index is greater than equals to 1 in the recursion like I have prefer recursion, so I'm assuming that you know recursion dp. If you don't know, then you will not be able to solve the problem. You can ask your uh, uh, queries in the doubt in the comment section. So when your index is greater than this, so this is the base case, and when this is happening, so you should check that if what if that we have to also make sure that body part. So if my body part weight which we have in the state. So we have body part less than equals to total minus body parts. This is this. Sorry, this should be like this. Okay. Total what total we have body part and your total body part. Okay. So this value will give me total head weight. Okay. So when you do this, you will simply return zero. Okay. And else we return some very large value, which is something around minus 118. Why we are returning zero? I'm explaining you because many times many candidates get like confused why we are doing this. So I hope the like implementation is very clear to you. So now it's time for the code. See what I did. I just make a try. Like first of all, I made try a new like data type so that I can store all these three configurations. Then I simply mention the DP, which is the standard things, and just take a sum to just send the sum. Like here I did na. Here I did this total sum. Okay. Then what I did I simply db sum just for the uh, like um, like debugging that's a kind of stuff. And now just my this is answer. Okay, see what I'm doing here. So I'm just always doing this. I don't know why, because like this helps me debug the statement. So just always try to add some console or cout statements to debug your code. Okay, so I just told you that I had to keep in take index, take vector, intent, and intsem. So if you are this is the base case, as I told you, if you are at CS, that means that you had iterated on your array and you have some valid configuration in your hand. So if your take is greater than some minus take, simply return zero. Why I'm returning zero? See, listen. I'm explaining you, and then I'm returning some very large value, like very negative value. Because see, when we're returning zero, and you're taking max. So whatever the sum I have at that instant, that will not get affected. Means that is the answer. So that's why we want like this could be answer, right? This could be like this could be answer, right? So if this is the answer, so just return zero. So whatever the answer we have at that time, we can keep that answer. But if that not, so just make it worst. Worst means that never can be your answer. That never can be your answer. That's why I'm just returning a very large negative value so that your answer gets spoiled, right? And this is also the same case. You don't want that index greater than n, and this is the memoization step, and this is the answer. I'm just using this, so one long. Okay, so that you can always like you don't get overflow. And then just two cases, index plus one, you had take plus back index dot a means you had taken the body part, okay, and here you had taken the like back index dot c means you had like add the body part, and you take plus one, you didn't take means you didn't add to the body part, you add to the head part, okay, and you add the head part material and simply return the DP. So it's a very standard knapsack problem. If you like know, then you can solve this problem in just 30 to like not 30, you can solve this problem in 20 to 15 minutes. Okay, It's just about implementation. So I think we had tried, like I had explained you four problems. So that's for now. The E problem I was not able to solve. Like the one thing I was able to figure out that we can have the must complexity is this. So something BFS kind of thing we can use. But in the contest, I was not able to figure out that thing. But I hope I will, as I will solve this problem, I try to upload it if I have time. So just, like I want to know your ideas. Please give me in the comment section about my explanation and all that stuff. Till then, bye bye. Thank you. Thank you for watching my video.